Hello, and welcome to the third in a series of short videos showing how to calibrate the LA19-13-04A VNA. This particular video shows how to do a calibration to carry out a mixer measurement. So here we have the arrangement that we're going to use for this demonstration. We have the LA19-13-04A VNA. On the left-hand side, we have a signal generator to give us the local oscillator. We also have a power sensor that we're going to use to calibrate the signal level from the VNA that will be used to drive the RF port of the mixer. And of course, we have the mixer that we're going to test. Note that we've used quite thin cables here, and you need to be a little bit careful because you can get some very good quality RF cables. Some available are referred to as mini-bend. They can give you very good performance, and they're very easy to use, and they're very flexible. But you need to treat them with care and to make sure that there's no damage to the ends of the cable. That can cause quite large VSWR problems. Okay, so if we now have a look at the user interface, the first thing we need to do is decide the test signal level from the VNA and bandwidth of the measurements that we're going to use. So we can use the enhancement menu here. And we've got a 1 kHz bandwidth. That's fine for this. And I'm going to select -3 dBm for the test signal level. I know that the mixer we're going to use has got a 1 dB compression point of around +1 dBm, so -3 dBm is perhaps a little on the high side, but good enough for this demonstration. So we click Apply, and we can close the form. Next thing we want to do is to select the calibration kit that we're going to use, and I know we're going to need a female kit, and we have the serial number 844 here with me, so I'm going to select that and apply. Close the form, and you're ready to use that kit now. Now we need to go to the mixer measurement menu. So that's under Utilities. We select Mixer Measurements, and we're presented with a choice of 3 types of measurement. The first one is perhaps the most common, and that is conversion loss and return loss from the RF and IF ports. The other measurements are port-to-port isolation and conversion loss compression. However, for this video, we'll just use the first type of measurement, so we click on that. So the first thing that we'll need to do is to tell the software what external instruments we're going to use to support our calibration and measurements. So we click on the instruments and select LO source and power sensor. So we select the signal generator that we have, and I'm going to use a Pico Technology AS108 for this demonstration, and a Keysight U8480 power sensor. Once we've selected those two, we can click Apply. And we should get some text on the nearby boxes telling us that the instruments have been found, what their serial numbers are, and so on. And if that's the case, we can close the form, and we're ready to go. We now go here to the top set of text boxes and radio buttons, and this is where we tell the software what measurement plan we want to use. So first of all, we have 3 radio buttons, and with these we can choose whether we're going to sweep the RF frequency or sweep the IF frequency. I've selected a sweep of the RF frequency and selected that we're going to sweep from 50 MHz to 3 GHz, which is just within the bandwidth of the mixer that we have here to test. And we're going to tick this box here that says high side. This means that the software knows that we want the LO signal to be on the high side. If we don't tick this box, the LO will be on the low side of the RF. Next thing, we tell the software what IF frequency we want, and I'm going to use 30 MHz. Here at the bottom, we have the number of measurement points, and I've written 51 in there, which is a reasonable number for this demonstration. Finally here, in the top right box, we can put in the level that we want for the local signal generator. This mixer is rated at 10 dBm, so that's what we're going to use here. Now we're ready to apply, and those values are now set. Next, we come down to the first stage of the calibration. First of all, there is the reflection calibration. This is useful for correcting the effects of poor VSWR. Some mixers can have very large VSWRs, and that will lead to fairly high ripple in the measurement results. So if you want to do a very quick measurement, you can tick this box here that says Ignore, and that will just ignore the VSWR errors, but we want to do a proper calibration this time. So we can start by clicking this box at the top here that says Short Open. And this tells us that we need to connect a short to port 1 and an open to port 2. And we can see here in this photograph an example of what that would look like. Okay, so after having connected the standards, we click OK, and the measurement is done. The next thing is to reverse the calibration standards, so the open now goes on port 1 and the short on port 2. Here we are. This is what we need to connect to the ports. Once the standards are connected, we click OK, and the measurement is done. Now we need to do the loads. So we click on Load, and the dialog tells us that we need to connect a load to port 1. And here we are. This is what we need to do. The load is connected to port 1, and whatever is connected to port 2 does not matter. Alright, so we click OK to make the measurement. We now need to connect the load to port 2. Alright, so here is what we need to do. And we click OK when we are ready to go. So now we have completed the reflection measurements. We now need to do the through connection. So we click on that, and that tells us that we need to connect port 1 to port 2 using the calibration through adapter. Okay, here we are. This is what we need to do. Click OK to make the measurement. And now we are done with this stage of the calibration, so we click Apply. We now do the final step of the calibration, and that is to use the power sensor to calibrate the power level from port 1 of VNA. Okay, once we have the power sensor connected, we are ready to go. Here is how we need to connect the power sensor to the end of the cable from port 1. We then click OK to make the measurement. And there we are, we have done the calibration. The next stage is to connect the mixer we want to test. Here we see what we need to do. Once we are happy we have made the right connections, we can click on Measure to carry out the measurement of the mixer. And there we are. We have a plot of the conversion loss of this mixer from 50 MHz to 3 GHz. On the bottom, we have a plot of the return loss of the RF port of the mixer. You can see that we have a return loss of no worse than about 8 dB, and a conversion loss averaging around 7 to 7.5 dB. We can save this calibration by simply going to the File drop-down menu and selecting Save Cal. We can also save the measurements by selecting Save Measurements, and if we want, we can also change the scales of the graphs. And finally, we can also print the graphics that we see. Thank you for watching.